Is anyone trying to speak?
I just joined, and
okay. You sound good. Thank you.
And it is now 9:03. We have so hello everyone. It's been a bit, so welcome back to our regularly scheduled programming. There's a bit of ambient noise from someone. Anyways,
it's from Quincy.
Let's see. Okay, I'm not able to mute anyone. I don't know why I don't have
You
power.
muted.
Okay. Sorry about that.
No worries. Thanks. So today we were going to discuss the OCP Attestation 1.1 update. Unfortunately, the primary authors of that had a last-minute hard conflict and were unable to make it, so we'll have to reschedule that. I thought today we could do a quick round robin or something just to kind of go over the presentations that happened at OCP in Lisbon and discuss anything that folks think is of interest there. So let me pull up the track sheet. This will probably be a relatively short meeting, given that, no one's on point to present anything of a huge amount of material. That's fine. Overall, I think it was a pretty well-attended regional conference. I believe it had significant more attendance than Prague we had last year. And yeah, I like the topics we had. So there was empowering firm security, the indispensable role of SBOM for end users. So this was a discussion of the landscape of SBOM and some of the technologies coming down there. If any of the authors of these presentations are on the call and want to chime in and give a quick recap, feel free. I know that I didn't advertise this, so it's fine if not. And if anyone has questions or comments about any of these topics, feel free. Recent and upcoming security trends in the cloud level hardware devices, a survey. So this was IOActive, auditing firm, talking about some of the issues they found with hardware devices and particularly storage devices. So this was pretty interesting for me. We didn't have a lot of time to ask questions, but yeah, sounds like there's some interesting problems that are happening with some of these devices. We had a Project Calyptra update. So we've hit 1.0 for the specification, RTL, ROM, and firmware are all tagged on GitHub. And we had some discussion about some of the next things coming, particularly post-quantum support will be coming around the corner. And there was some other discussion about new features like stable identity and flashless boot. OCP lock, this is a talk that I gave along with Eric Eilertson. This is introducing a new Calyptra-esque IP block whose role is, so Calyptra by contrast is an IP block for root of trust designed to be able to fit into kind of any interesting piece of silicon that you might see in a data center that needs identity features. It's not tailored to any particular role. Like you can go into a BMC, into a NIC, into a CPU. Lock, by contrast, it wants to be the same kind of thing, but is scoped specifically to storage devices. So there was some discussion about the motivation behind that and the high-level design. Still a pretty new effort, so not a lot of concrete details out right now.
So is the expectation that lock is going to be hardware that is going to be required in all the existing SSDs, just like by certain buyers, sort of like Calyptra?
Yeah, that's the general idea. Yeah, sort of like Calyptra. I mean, obviously it doesn't exist yet, so we can't like require it anywhere right now, and it'll be some time before it's ubiquitous enough that the supply chains have a chance to catch up. But eventually, that's the idea.
And is this, so if I'm an SSD vendor, then would I have to incorporate Calyptra on the one hand and then lock on the other, or are those two going to be combined into one?
Yeah, that's a good question. I'm thinking, or we are thinking, Calyptra is part of this. Like it leverages some features from Calyptra, so it's not super meaningful to take lock without Calyptra. There's some ongoing discussion about how to make it more easy to take lock. Like, one block is easier than two, so TBD on all that. But
okay,
yeah.
Thank you.
Mm-hmm.
So, what is the key management role here that I didn't understand?
What is the key management role?
Yeah, what is the key management? Because what I understand, Calyptra is providing a set of runtime services like DPE and measurement and attestation, those kind of stuff.
Mhm.
But I'm just wondering, what is when you say key management block, what are the extra functionality that or API that the group is trying to provide here?
Yeah, so in a storage device, and I'm going to talk about self-encrypting drives specifically because that's kind of the target audience for this device.
Okay.
You've got media encryption keys that are generated and safeguarded within the device and managed and all that, loaded into and out of the hardware crypto engine. So the idea is that on a lock-equipped drive, the media keys would be generated and only ever visible directly to the key management block. So the controller firmware that handles TCG, Opal, all that business can ask lock to generate media keys and to load them, but can't ever see them itself.
Okay.
So lock is analogous to what DPE is to DICE?
Essentially, yeah, it's key management as a service, essentially. Now, one of the technical hurdles here is that, like Calyptra, lock would not necessarily own its own flash. So the only thing lock can remember is things that are in fuses, which means if you want to like generate a media key and remember it for later so that you can decrypt your data again, you got to offload that in some encrypted fashion to this controller firmware so it can put it in flash somewhere.
So basically, in Calyptra, all the keys are actually stored in the key vaults, right? So there are key vaults where you store all the dice keys and CDI values and all that thing. So are we expanding that role to store the media encryption keys? Is that the?
Yeah. So so in Calyptra, these identity keys. Well, two things. At rest, like when you turn the device off, those keys are essentially all stored in fuses, or at least are like
Yeah.
the root keys are in fuses. And then at runtime, we then go churn a KDF and make all the runtime keys, and then they live.
Yeah. So all the dice keys, they stay in the key vault, right?
And they remain in the key vault, and the firmware can then leverage those to sign things or whatever, but they stay in the key vault. So not even Calyptra firmware can leak the keys if it wants to. So that is a property we want to maintain for KMB. Media keys are only ever like exist at runtime in something which walks and talks like a Calyptra key vault.
Okay.
There's also one other like effort of this is to provide a better way to bind a media key to some kind of external seed or password, which you can store in a TPM or elsewhere on the motherboard or off in a remote key management service. Like the problem, like that kind of thing is desirable because then if someone walks away with the drive and they don't also bring the motherboard with them, they can't decrypt anything. But the problem with this flow today is that like there's no encryption on the wire. The host has complete visibility on these passwords and it relies on admin roles, which are pretty privileged. So trying to think of some better APIs that rely on non-privileged roles with encryption on the wire so that you can asymmetrically wrap a seed or a password and send it down to lock. So that might be a new paradigm that lands in TCG Opal.
And Jeff, since the IP would be used inside of devices that people would want to get FIPS 140 certification for, could you speak to that? Are there plans to get the IP certified, if that's even possible?
Well, I can speak to how that kind of works on Calyptra, and I mean, it's a bit early for lock to be like solving that problem, but
okay,
I don't imagine they would deviate from what Calyptra does materially. And what Calyptra does is we've engaged with a FIPS validation lab to essentially look at Calyptra, imagine it was, because we can't actually certify or FIPS certify like Calyptra because it is not a thing you can buy. You can't go buy a Calyptra. You can buy a random other CPU that has Calyptra inside it, and you can FIPS validate that thing. But we're still like contracting with a lab to go look at Calyptra as if it were a module and run through the flow of certifying it. Don't actually issue a certificate because it's not a thing you can certify, but provide a template that here's all the things that a lab would ask for if this were in an actual module. And then that will make FIPS certification very easy for when I go and take Calyptra, put in my module, then I go get the template and say, all right, sweet, this FIPS thing is very easy now. So I'm imagining that would be the flow we'd want to pursue for lock as well.
Right, and the module will be, as far as the certification goes, hidden inside of Calyptra.
I think reverse, like
the
module would be Calyptra plus other vendor things that are needed, like a fuse block.
Oh yeah, it wouldn't be the only thing. Okay.
Yeah.
Okay, thank you.
I'm not sure where I got. My feeling is that what you're talking about here is something like the way the TPM has sealing or unsealing of data, that kind of stuff, right? That is what it looks like to me.
You're asking about like the role of lock as far as key management?
Yeah, like in TPM, we have a sealing and unsealing of data and the keys and those kind of stuff, right? So it seems very similar to that.
It's somewhat similar, yeah. In a TPM, you can ask it to derive sealing keys.
Yeah.
And provide sealed data and say, please unseal this for me, or please seal this for me.
Yeah, it's similar to that, yeah.
It's somewhat similar, yeah. Actually, since we have, let me just pull up a diagram that was shared because this is going to be useful. Because I happen to be the one to have shared this. Share this tab. So this was a slide from that diagram. Lock is this thing, and then we also have Calyptra here. These blocks are already there.
Yeah.
So now the thing I'm taking an analog of TPM, right? So the thing which does the sealing and unsealing is this AES crypto engine. As the data comes in over
Yeah.
PCIe, gets encrypted or decrypted. So all we need to do now is figure out how do we program the keys that are used to seal or unseal. Right now, the controller firmware manages all those and just programs them directly, but the idea is that we'd add this new block which has sideband interface, and the media keys come from here exclusively.
Yeah, that makes sense. Yes.
And then there's another little quirk, which is take a discrete TPM. That thing has internal flash of its own. It can remember the primary seeds, which are used to derive the sealing keys. And you can rotate those primary seeds whenever you want. If you want to like do effectively a crypto erase or a TPM clear. KMB only has fuses, and you can rotate data. You can provision new entropy and erase old entropy in fuses, but you can only do that a very small handful of times, which doesn't make it very easy to like. You can't really just make a new key and have KMB remember it and then forget it later. So kind of offload memory, long-term memory to the storage controller firmware. But this thing would only see encrypted blobs. He has to feed them back to KMB to actually get them to turn into keys.
Yeah. No, it is clear now.
Mm-hmm.
Is this presentation available on the OCP site, or can we get a copy of it?
Let's do I zero no. Huh. Okay.
Yeah, it appears to be available on the Summit website.
Is it okay? Could you post a link in chat?
Yeah, I'll put a
Or
Thank
also
you.
in the minutes. That'd be great. Yeah, thank you. Yeah, we uploaded them all to the thing, so they should be available. And there's recordings too on YouTube now.
Just a comment on this and in the context of things like Opal. It seems like it's very much kind of short-circuiting a lot of things that happen inside of Opal, which feels very clunky to me, because there's a whole lot of kind of key management that a device that needs to support something like Opal ultimately needs to do to be able to support all the complexities that Opal provides, like flexible access control and stuff like that. This feels more suited towards something like Keeper IO, where it's a more direct kind of use of keys, and there's less kind of storage controller key management that is needed to be able to continue to adhere to the standard. Yeah, just
So yeah, thanks for that feedback. We have been thinking about how to map all this to Opal and Keeper IO, so that regardless of which one you're using, you can use KMB under the hood completely transparently. I did mention there's some new APIs coming that would allow you to more securely bind things to external seeds, but you don't need to use any of that, would be the goal. Do I have... Yeah, here's an illustration of how you can bind a key to multiple seeds, like an external root seed that the CSP would control and the media key seed that the customer would control. But you could imagine, like, I'm gonna just look at this right here. So you mentioned like flexible access control, as in you can have multiple users that have access to the same media key.
yeah.
Yeah.
Yes, there's a whole lot of complexity that Opal has to do to be able to support things like that, in terms of multiple layers of wrapping keys and stuff like that. And I think what you're ultimately trying to do is the bottom layer key, the media encryption key, let's say, we want that to somehow be influenced by something that's coming from outside of the device, which is not what Opal typically provides, right?
Yep. So one could imagine that you make a key which looks like this, where this bottom layer auth secret is what comes out of like the multi-party authentication. So any one of n different users can unwrap this thing, and then controller firm would feed this into KMB and say, okay, now get the media key out. And then there's nothing, I don't have to like provide an external seed here if the user did not opt into it. But I think, yeah, it'd be great to keep keep chatting about this. I have some regular updates because I think it'd be great to get your feedback and others as well on making sure that what comes out of this is viable for all use cases. I'm happy to keep yakking about this, unless if there's anyone else had any other questions, we can keep moving on through the other talks. Cool. All right.
We should probably encourage people to come to the lock meeting if they can.
They can't.
A priori. Okay, yes, unless they're signed it. Yep, got it.
Jeff, not to divert from the lock conversation, but you mentioned there was a session on post-quantum crypto.
Yep, let's go do that.
I'm particularly curious if there were any sort of developments there, because the CNSA 2.0 stuff seems to be one of the pacing drivers, and I'm wanting to know if there's anything else that's emerged like it.
Yeah, let's get to that. I'm going to just cover OCP Safe first, just because it was next.
Oh, sorry. Go ahead. Yeah.
No worries. Yeah. So yes, there was an OCP Safe update, basically just giving a perspective of what how things are going. We had basically a customer, supplier, and validator on stage to talk about how things are going. So that was cool. Things have been going well. We're getting a number of different auditors signed up. Okay, post-quantum. And it's really exciting. So this was a presentation by Microsoft about an open IP block for doing post-quantum acceleration. It will be making an appearance in Calyptra, so that's cool. Now, I guess you asked about CNSA 2.0. I don't think that necessarily was part of the presentation. This is more the technology of how to do secure hardware with these algorithms. But I do have thoughts about CNSA 2.0, which is, it looks like, they recently issued an FAQ update, and part of that was informed, but part of the content of that FAQ was informed by conversations that I've been part of with NIST about LMS key management. I think, as I shared earlier in this forum, quite a bit earlier, I think it was sometime last year, NIST currently does not allow for realistic LMS key management. It says it's got to stay in an HSM, no offline backups, which is really unfortunate for keys which need to last decades. And then CNSA comes along and says, you've got to go start using LMS by 2025. So what's happened since then is NIST has had some workshops working with industry and has basically signaled they understand that their current requirements are too strict, need to change to be realistic. It's going to take a bit of time, but they've heard feedback from the industry on how to do safe state management for keys, for these stateful keys. CNSA on their part has said, if you want to have a device that supports LMS, they're gonna look at the verification side, specifically for secure boot implementations. The device is just verifying an LMS signature that's not actually emitting it. And they're just gonna look and make sure the verification is solid, and then trust that the signer side is keeping the key in state safe. They're not gonna require that the signer keep their keys in an HSM all the time. Others might. others might, other customers might have that kind of requirement saying you got to keep your keys in HSM because the risk of state reuse is too great, and that's okay. But it will not be a CNSA requirement. Now, Sphinx Plus is a thing which is great because it's also hash-based and it's stateless, but it has a downside that CNSA does not support it. And both I and others have tried many times to get NSA to adjust course on this, but they remain firm in saying Sphinx Plus is not allowed for any use case, including secure boot, which is kind of unfortunate.
They've also added Crystal's dilithium as okay to sign firmware, so that was delightful.
Yes, that was great. So,
hi, this is Lance from Micron. To that particular point, has there been discussion about SPDM response signatures and only being able to use Crystal's dilithium? Or is that outside the scope of this particular discussion?
So that's kind of outside the scope of this particular discussion. If you are interested in SPDM support of post-quantum, I would go get in. I don't know whether you are or aren't a member of DMTF, but that's where.
Fair enough. Thank you.
That's where the work is happening.
But Jeff, I mean,
yeah, I can't say it is on our radar.
Yeah.
Yeah, it is.
Regarding Calyptra, I understand that for identity operations, we're using ECC still. Do you see PQC taking over that? Any implications for identity?
It is definitely on the roadmap and is one thing we want to tackle as part of the next major rev of Calyptra. There's two aspects of two areas of post-quantum that would affect Calyptra: secure boot and attestation. So secure boot, we have LMS in 1.0, getting new accelerators there. We'll see if there's anything else that needs to be done for secure boot as part of the next major Calyptra revision. But yes, attestation is still ECC. Some hurdles there are want to get the hardware support for accelerators. Like can't do LMS for attestation. Sphinx Plus has that problem of not being CNSA 2.0 compliant. So looking at dilithium, so we'll need hardware support for that. Also, we need the DICE to support post-quantum algorithms, and we got to settle on how to handle or not hybridization. So
yeah, that's that's a tricky issue because NIST and NSA don't seem to be of one mind.
Yeah. NSA seems to indicate like we're just fine with dilithium, no need to hybridize. Everyone else disagrees. So from an implementation and standards spec perspective, like I would love not to have to hybridize. It seems like a major pain for many reasons.
Well, the certificates are pretty messy, and that's kind of an open issue still with the IETF.
That's my understanding. Yeah. And then there's the bindings to things like SPDM, how that would work. Because we got to make like one of the big use cases for Calyptra, like it's got DP inside it, and what does it do? Well, it signs stuff for an SPDM responder. That's not the only thing it can do, but that's one of the big things it can do. So we got to make sure that whatever SPDM comes out with for their post-quantum support, that DP can handle. It's possible that Calyptra might target or flavor of post-quantum support which isn't quite rich enough to match everything that eventually comes out with all the new ASN1 and SPDM flavors, and then maybe a point release will patch things up. Hard to predict the future. Yes, this was a timely topic. Is there anything else anyone wants to talk about post-quantum? Okay.
I just a question. There was mention of crystals dilithium being kind of updated to be acceptable for firmware signing. Where is that listed? Is there any document or anything that's been updated that?
Let me find it.
And I'm noticing it in the CNSA document, but I'm trying to make sure that is the actual update, or if I just missed something previously.
There is a
Yeah.
version 2.0, CNSA version 2.0 was published last month. I just pasted a link in the chat.
Okay, and that as part of that update, that's when they added that then?
Right. So, yeah.
Okay.
Yes.
It's just confusing because it's still version 2.0. 2.0 was technically released 2 years ago, right?
So yeah, CNSA 2.0 was released like September
22.
Yeah, 22. So this is not CNSA 2.0. This is a FAQ. This is an FAQ for CNSA 2.0.
I think, Jeff, they're calling this as a CNSA version 2.0. CNSA 2.0 version 2.0. It's very confusing, but FAQ is the one they updated, but new algorithms, title says that, but if you look at the, just scroll down, it clearly says, see that end of each page, there is a footnote kind of thing, you see? It says version 2.0. I think I saw some other places they reference, this is CNSA 2.0, version 1.0 was the previous one, this one is version 2.0. That's how they're handling.
That's an awesome versioning scheme.
Yeah, very confusing, but that's what they did.
Okay, well, I stand corrected. Thank you.
Is it 2.0 the FAQ?
It's so the document where so original CNSA was just a website. When they did the 2.0, it was published as a PDF as a CNSA 2.0 and FAQ. And now they've updated that to, it's still CNSA 2.0, but now apparently the document is version 2.0 as well. And that's where they've added the change of saying that crystals dilithium is a lot also acceptable for firmware signing. And I don't know if there's other changes. I can't see anything in here in terms of like what has changed in this version 2.0.
Yeah.
That's why I'm asking about it, because it's confusing. It's not clear what all has changed.
I remember looking through and finding a couple of spicy Q&As. Let's see. Strong.
Yeah, I know one change was they mentioned the relaxation of the rules around LMS on HSMs.
Yes.
Because all the HSM vendors have complained a lot.
Yeah. Can I use tree?
Yeah.
No, can't. Yeah, that was funny. So if you were hoping to use multi-tree for your offline backup needs, nope, doesn't work. Can I use Sphinx Plus? No. Yeah. Which components need to be validated if you're doing LMS? So yeah, this is the bit that answers that. Do I need to keep my keys offline? Signature verification is expected to be performed by code. Sign code and receive provided sources. If your product is only validating signatures, like for secure boot, CAVP testing is always required, not CMVP testing. Code sources signers that are NSS are required to produce signatures according to 208. Waivers will not be granted for this. Code sources signers that are not NSS are not subject to CNSA requirements. they are expected to use the same development practices, so code that can pass CAV testing. One should implement signing and state management in hardware such as HSM. Backup flows, which may involve transferring keys between modules, must prevent state reuse, but are not verboten.
I guess this is the result, or at least partial result of all the discussions that's been happening, is them trying to provide guidance that we're not going to disallow backups now. But here's a word of caution: you need to be careful with state reuse.
Mm-hmm. No, you can't use SHA-3 unless it's in this LMS. Will NSA add more selections to CNSA in the future? Does not currently plan to add any more post-quantum standards to CNSA. Circumstances could change in ways we do not currently foresee, but adding more algorithms generally makes interoperability more complex, although admittedly less so for algorithms for software and firmware signing. So this is, I think, them saying, please stop asking us about Sphinx Plus or any other of the other algorithms. One of the circumstances I believe that could change is if they find that the hardware that they really need to buy doesn't support LMS and only supports Sphinx Plus, then they could do that. I'm aware of products which kind of committed to Sphinx Plus and can't change course now, so they'll be on the market for some time. But I do know that NSA is very, very, very conservative about interoperability. So cool. Any other topics for post-quantum? All right. Oops, I meant to pick a different button. Sorry. I'm doing share that. Okay. Recovery from firmware vulnerabilities and TPM. So this is a talk that I gave about some new APIs that have come out of TCG, basically to provide a meaningful way for a TPM implementation to use DICE under the hood to attest to its own firmware identity, so that you can fix a bug and know it got fixed. Then rekey everything so that you're using new keys that couldn't have been leaked by the old firmware. As of now, it's only part of the library specification. It's not mandated in any profiles. But now that it's there, people can start asking for it. Assessed TLS and formalization. So this was a talk about basically gluing attestation on TLS and then formalizing that with formal verification. So interesting use there. This was a talk about a low-level hardware IP, not necessarily block, I suppose, but technique for detecting tamper attempts for fault injection. Also, I believe the materials indicate this is purely digital, so not relying on any analog components, which is pretty neat. And we finished up the session with an update on OCP flashless boot. A mechanism for allowing boot media to be provided to a device without it reading from onboard flash. And that's nice because it means there's one less stateful component that has to remain, like, have firmware integrity, and therefore possibly one less root of trust which needs to exist on that component to guard the flash.
I actually have a question on that. This is Jim Yastik from Macronics. Do you have a sense of the timing of that being implemented?
I do not. I'm not part of the core team working on this spec. My gut sense is that within a year or two, it should be finalized. I don't know. Hardware timelines are what they are, right? So, not sure when it would actually arrive as a product you could buy.
Yeah. Oh, okay. All right. Thank you.
Mm-hmm. And that is it for.
Hey, I really apologize. I joined late. If you don't mind, can you cover OCP lock?
Yes, we did spend a bit of time on lock, and I'm happy to actually have a dedicated session on this call later about that.
Okay.
So, yeah, I think there'll be time for that for sure.
Yeah, Jeff, there was a question in the chat about joining the lock meetings. You just might want to mention there's a license agreement to be signed first.
Yes, there is a CLA. I don't have all the legalese in front of me, but feel free to shoot me an email and I can route you to all that. So I think we have 15 minutes left in the call. I don't think there's any other topics. So I'm happy. I'm totally happy to spend the next 15 minutes going over lock for anyone who wants to stick around for that. It'll basically be a bit of a rehash of what we talked about earlier in this call. So if anyone else feels like stepping out, feel free. And thanks for coming.
Hey, Jeff, before you do that,
yes.
So just thinking ahead to the global summit this fall, any thought from a security project perspective on sessions that we want to make sure are there, or is this too early to? I'm just thinking coming out of the regional summit, whether we want to get people sort of plugged into to do certain sessions.
Yeah, I think now the last global summit had some interesting talks about like secure manufacturing standards. We had a flashless boot talk there. I think, and then we also had ownership transfer as well. My kind of high-level idea would be that any of the work that's kind of up in the air right now, regardless of what stage your execution is at, it'd be nice to have talks about those. So that'd be Calyptra, lock, ownership transfer, flashless boot, etc.
Any sort of cross-pollination? I mean, we talked earlier a little bit about SPDM, so
yeah. So I know for SPDM we're planning. We would like to do an SPDM post-quantum discussion at OCP.
Oh, great! I'd love that. Bring it on. Cool. Yeah. Thank you, Eric, for the call out there. Any other last-minute topics? Okay, cool. Well, sorry, next week, it's the 14th, we will have to cancel that call just because there's quite a few people who won't be able to make it due to another conflict. So see everyone on the 21st, when I will hope to have the attestation 1.1 discussion. We'll see if we can make that work. Okay, with that, I will do a lock revisited. So yeah, Chandra, did you have any particular questions about lock?
No, not any particular question. I would like to understand better on the threat model or the problem to be solved.
Yep.
And later on, obviously the leading part is where there are overlaps with or adjacencies to the Opal and the Keeper IO specs that that are out from the TCG, where there is collaboration or whatever, right?
Yes, awesome, great topic. So let me go back to this.
Can I add to that? I'd like to get a little bit more understanding of what the use case is for lock. I'm not sure. You said I heard you said that it's primarily meant to be in storage devices, but why is it in storage and not in other devices? Sounds like you were also talking about a key management vault of some sort, but that could be useful in a lot of different devices. Why focus on storage in particular? And then I'd like to understand what Opal is. If people could say mentioning Opal, I don't know what that is. Can somebody who knows explain that to the group too? Thank you.
Yeah, those I should be able to cover that stuff in this deck, which I'll run through. So, motivation, why we care about storage. It's a tricky problem, is that we get these devices, we fill them up with user data, and then we want to get rid of them. And they still have the data on them, and we cannot allow that data to escape because it's sensitive, reputational harm to both our users and ourselves. So that's not happening. So we shred a bunch of drives by default. That's the safest way to make sure the bits don't leave. Produces a lot of e-waste, affects our bottom line. We don't like shredding drives. So overwrite is a technique to make a dirty drive clean again. Just make sure every bit of the drive can be written over multiple times with random data so that a forensic lab couldn't recover any data on the drive. Problem is there could well be sectors of the drive that aren't writable for various reasons. It's reached the problems. So, and if any part of the drive can't be written to, we're going to trash the thing. So we still shred a lot more drives. It's also a problem if it's an NVMe drive and it's got flash on it. Some of those portions of the disk, those pages, might not even be addressable by the host. They've been hidden by the controller, and therefore, and they might still have user data on it. So overwrite's really not a viable option for those kinds of drives either. The solution to both those problems is drive encryption to make sure that all the bits that are on the disk are encrypted to some key, which you can then forget. And then once you've forgotten the key, it doesn't matter if you've actually overwritten the bits on disk that are all random ciphertext that you can't recover anyways. So NVMe self-encrypting drives are a thing that do this. The drive manages the encryption keys, allows you to granularly map the keys to different address ranges, and allows you to have different users, which you can map those keys to different user accounts as well. And you can do fancy things like saying multiple users can have access to the same key. I think that's what Thomas Bowen was discussing earlier. This is Opal. If you're asking what Opal is, it is the API that allows you to do this kind of thing. Now, I know I'm overly simplifying it. I have not spent a huge amount of time exposed to Opal and actually working with it. Others on the call, I don't know, Thomas, if you're still around, is that
Jeff? Do you want to mention, Jeff, where the Opal standard resides?
Yeah, it's in TCG, like the Trust Computing Group.
One minor comment, the self-encrypted drives is not strictly bind only to NVMe protocol, but to many others. And it is TCG self-encrypted drive. It's a better term to, yeah.
Yeah, I mean, Opal, there is TCG Enterprise, which is a little bit older protocol, and it applies to SAS, SATA, NVMe drives. Hard drives, flash drives, it's has multiple applicability.
So let's say you've done this, you have your keys managed by your drive, and you can ask the drive to forget the keys. That's cool. But someone might actually just, one threat that cloud service providers must face is that someone could just go steal the drive, break into the cage, whatever. There's a lot of drives out there, and they might not all be physically secured in safes. So, and if someone steals that, cool, yeah, all the bits are encrypted on the disk, but the keys are there too. So that's not a huge help, because a determined adversary could recover the keys and obtain user data.
Yeah, but typically the encryption keys are wrapped with a key that is held externally to the drive, so that doesn't happen.
That's a thing you can do, right? You have to opt into that, and that's the mitigation here, is that you wrap the keys to something held off the drive.
Well, but that's Opal. If
yeah, that's basic Opal.
Yeah, Opal does that.
Yep, Opal does this.
Yeah, so probably maybe there is a distinction when you were talking about no external access key or authentication key. Those drives are colloquially referred to as ICE drives, or instant secure arrays capable drives. Probably you were mentioning about that. And then the Opal or other protocols, Ruby, TCG Enterprise, everybody goes with this mechanism wherein the external authentication key controls the access to the media encryption keys. Yeah, please go ahead.
Yeah, this is, I've roughly illustrated. I'm trying not to bring in too many deep Opal isms, but one way to do this is to create an admin account and have the admin password be stored off drive, and then transitively the password is used to encrypt all the keys.
Yeah, I think that the principle that is important here is that the keys are not kept on the drive, right? The key for unlocking the encryption key is not in the drive.
Yes. So here is a very oversimplified diagram of how that kind of could work in practice under the hood, where the admin password is provided to unlock the drive. It is used to decrypt an admin secret, which is then used to decrypt the media keys, which is then used to decrypt the media. The only things stored persistently on the drive are these encrypted admin secrets and encrypted media keys. Nothing works unless you actually provide the admin password. So this is good. We like this. But the problem is you could very easily have a very broken implementation, which appears exactly the same from the outside. It has all the same behaviors, but it has this critical flaw in that we're just comparing password hashes and not actually using the password to encrypt anything. And you're storing the admin secret persistently on the drive.
Looks very similar to BitLocker, right?
I couldn't speak to that.
And
so
Microsoft
BitLocker used to leverage implementations like this until a few years ago. Microsoft stopped doing that. There was a big public blog post about it because they started finding broken implementations like this. So BitLocker does all the encryption on the host. It doesn't rely on the encryption on the drive anymore.
And that's one technique too. Just say, I'm not even going to trust the drive at all. Do all my encryption on the host or on some kind of interposer. Both those have costs. And so it would be nice to be able to trust a drive to do this properly.
Yeah, fix the problem instead of creating band-aid solutions.
Other broken implementations, you could go even worse and say, we're just going to store the media keys on the drive persistently and not do any wrapping at all. we could have an implementation where the crypto hierarchy is just nice, but once the media keys are unwrapped, they're susceptible to extraction via external interfaces like JTAG or UART or some glitch attacks. So finding all of these issues is a chore for cloud service providers.
So are you, when you say chore, are you meaning going through the certification process?
Yeah, all that.
Those
Yeah.
vulnerabilities don't exist.
Yeah, like we have SAFE, right, which is attempting to like amortize that cost, but it still is a cost.
Mm-hmm. Now, also outside of that, there is FIPS or common criteria certification mechanisms.
Yeah. I don't know. In my neck of the woods, we don't generally give those validations a huge amount of weight. Like our customers want them, yes. But as far as like, is it actually secure?
The common criteria for something like Pro is probably a lot more better because it's.
Yeah, you're right. You're right. That was too much of a blanket statement.
Yeah, I can see why you'd not necessarily trust FIPS to guarantee that you're doing all this wrapping properly, but the protection profile that Opal certification is tied to actually expects the evaluator to check for this proper wrapping and stuff like that. So to make sure that it's actually bound to some kind of key that comes from outside of the device.
Mm-hmm.
Yeah, so this is a question I wanted to ask about this, right? I understand that there is implementations that are not good, that do things like what you're showing here, right? In my opinion, those implementations are not compliant with Opal, right? For example. So then the question is the solution to this to come up with a new standard, or to say we're going to do the implementation so other people don't screw it up?
More the latter. Kind of like how Calyptra is not a written standard, it is an implementation.
Mm-hmm. Okay. Yeah, it's the same concept as Calyptra. Got it.
So I know we have just a minute left. So the overall problem is critical to get these storage key management right. Threat model is significant. Implementation is very in quality, and auditing them is a chore. So we have Calyptra as a template. Like, hey, we had a similar shaped problem for identity. Like dice is critical to get right, or just identity is critical to get right. Significant threat model, can we just solve it once everywhere? So ergo Calyptra. So we want to do lock, which is the goal would be to do a similar piece of work in a similar venue, also Chips Alliance. Scope it to storage devices, because that's where we have this problem. Now, I think there was a comment that key management might be useful for other areas, and that is interesting. I think that'd be nice to support. I think our thinking right now is just trying to make sure we nail the critical use case in front of us. And once we've done that, if there's tweaks we can make to open it up and make it more useful, that'd be cool too. I can't speak for the product or for the entire project myself, but on the face of it, that doesn't seem very bad.
So Jeff, another question with this stuff is the aim here to make a secure implementation of Opal or a secure implementation of Keeper.io, right? Those are the two that I know that do this kind of stuff.
Not necessarily, no.
Or is it to define a new standard and do a new implementation of that new standard?
The goal is, so here's a diagram, and I know I'm going to just spend a very short, you know what? I think we should revisit this, actually.
Maybe even before we go there, Jeff. Alberto, do you know what the ultimate problem is? It comes down to implementation. And as device vendors, or as let's call it, say, hardware manufacturers, everybody associates with their company and has a distinct identity with that company. But the reality of outside of the hardware world is that very few people can name hardware companies, like aside from the big ones, maybe Intel and Nvidia, but very few people could tell me who the top tier SSD providers are. If I go out and I talk with friends or colleagues who work in CGI and they work in IT, just doing maybe graphics and stuff like that. And I asked them, to name an SSD manufacturer or to name a network card provider. They don't know. But you know what they tell me? That they don't trust storage devices. And when we talk about the disposal in cloud and how we shred these drives, it's because although they can't name individual manufacturers, they know that once somebody had a defect or a buggy implementation of a certain protocol, and that has sank the boat, that inconsistency or that implementation has sank the boat for everyone. That's ultimately the problem that we have. And that's a problem that's unique to our industry. Like in our industry, we think, oh, we're so distinctive and my implementation is great, but my competitor's implementation is not. That's what really got us to where we are. And we're talking about storage specifically because those ones are the ones that are shredded at huge cost to both the manufacturers of storage devices. And just from a sustainability perspective, it's not good that these things are getting, turned to dust. And we have to do it because the confidence in the industry is not there.
So Brian, again, I understand Jeff had to drop, and I just looked at the PowerPoint a while ago. If the direction this is headed is, okay, the entropy source or the key material is outside the drive, right? Then you have TCG Keeper IO, which exactly does that, which is the actual media encryption keys do not reside on the drive. They are outside. So what is the overlap or what is the unique problem you're trying to solve with lock?
It's not just how the key gets delivered to the drive or whether the key is consistently stored or persistently stored in the drive. It's the key management as a total. If the drive is running, can debug access it? Can firmware bugs access the key? Can the key be exfiltrated at all out of the drive? It's not just, I think people are latching on to whether keys are persistently stored or volatile. That's not the case.
Mm-hmm.
Of course, that's one scenario that's addressed, but there's a whole raft of key management scenarios that we address.
Got it. And that's the focus you guys are bringing in from the implementation focused thing, right?
100%. And another standard doesn't help, but the existing standards all have taint. And if you work on those standards, sorry to inform you that they've all got taint, just like storage devices today have taint, and devices get shredded. The encryption capabilities don't get used. Instead, it's done on the host, like Jeff mentioned, or with interposers. So all of the efforts that's gone into that is largely wasted, and that silicon area is wasted too in those chips. We'd like to be able to reclaim that, but in order to do it, we have to start from a place where we're fully transparent about how it's happening and we're consistent in how we go about doing it. And if we can't accomplish that, then it's futile. We may as well take the capabilities out and retire all the standards because they're all defunct.
No, again, that's there is performance angle, right? Drives can.
I think there's huge benefit. Don't get me wrong. It's huge benefit to offloading it to the device. It's just it can't happen today due to the taint. So directionally, it's right, but on the opposite end of that, drives getting shredded for this this performance is not worth it.
Yeah, got it. Again, you're talking specific segments of the market, right?
No, I'm talking unilaterally across the industry. What we see from customers, it's not just cloud. Also in the enterprise space, we have huge enterprise presence. We talk with enterprise customers all the time. There's a reason that, BitLocker on client moved from the storage device into the client CPU. Just across our industry. And the more we stay in denial that this is actually a problem, that from foundational hardware security like this, if we think it's differentiating as hardware manufacturers, it's where we're fundamentally wrong. We don't realize that a mistake by our competitors or our peers sinks us all.
So I'm not convinced it totally replaces or better than the Keeper IO one, but how can I be part of this initiative? I mean, how can we join that?
Yeah, that's a good question. So right now it's a small focused consortium working on lock, but we can come back maybe next week or the week after and talk about expanding that. But I think right now the team is heads down, getting the first iteration of the standard and the first iteration of the implementation ready. Well, a good check. The more cooks you add to into that same kitchen, the pace is going to drop off for sure.
In this small consortium, are there
feedback in as well?
Are there any device manufacturer?
Absolutely, yeah. They those device manufacturers that recognize this problem and wanted to come out with a solution, those have all been part and we're part of the establishment of the little consortium that's away working on it.
Brian, aren't the 5 organizations public information?
Yeah.
Microsoft, Google, Samsung, Solidigm, and Kyoto are currently, working this set of issues with, I hope to get materials to a state where they can be made, publicly visible as soon as possible. But that, to answer your question, there are at least 3 drive vendors that are involved in this. Well, not at least there are 3 drive vendors involved with this.
Gotcha.
Yep.
And as to the TCG issue, all 3 of the drive vendors are very much aware of, Opal and Keeper IO, and I think we have a collective interest, at least from the drive level side, of trying to find a way to navigate what is being discussed around lock, but also not destroy the infrastructure and the investment that exists in the industry on for example Opal.
Yeah, that's a valid point. Yeah. So Brian, what's the next step? I saw, again, reading the presentation, I thought there was a spec to be released by a little bit later. So what's the real logical next step for this initiative?
Yeah, there will be a spec released in the future. To be about a spec and an implementation released, kind of following a similar model to Calyptra. Both will be released.
Okay. And is there any feedback opportunities, review opportunities? How does it work?
Of course, yeah. There's always feedback opportunities. The infrastructure for feedback right now hasn't been set up, but similar to Calyptra, there is that infrastructure in terms of the distribution, the mailing lists, and the Slack chat work groups. And then there's a weekly kind of public facing call on Calyptra. That infrastructure isn't there yet on lock, as it's much earlier, but that will come.
Okay, thank you.
Awesome. All right, we're way over. Thanks, folks, for hanging in there.
Thank you.
Thank you.
Thanks. And
Take care.
especially thanks to Brian.
Okay, Brian. Thank you.